All right, so video number 3 for 10-6 is a long set of notes today. We want to talk about when we need to pay attention to domains and ranges, because you can get yourself in trouble. It usually doesn't happen that way when you're picking t-values, because you'll realize that you have a problem. But when you are converting over to rectangular form, you have to be a little bit careful. So for example, we have this relation here where x of t is the square root of t and y of t is t squared minus 2. So if all I did was do the conversion over to rectangular, the steps would be exactly the same, right? X is equal to the root of t, so I could solve for t by squaring both sides. And then I could go ahead and plug into my y function, right? So that would mean that y would be t squared, or x squared squared minus 2. So I get this relation that y is x to the 4th minus 2. And if I just glanced at that, I would think that my graph should look like a parabola. However, I need to go back to the original and pay attention to domains and ranges. What do you know about x of t, right? If it's the square root of t, then by definition with square roots, I can only select values where t is greater than or equal to 0, because I need x of t to exist. So the domain of that subfunction, right, that parametric part, is limited. And in addition, right, I also know that if I'm plugging in values that are greater than 0, square root functions only generate values that are going to be greater than or equal to 0. There's no such restrictions here, right? T squared, I can get anything I want. I can plug in any t and I could get, well, I would have a limited range here, right? I would have to have values that were bigger than -2, but I could plug in any t value that I needed. But this has to transfer over to my rectangular side, right? If I can only plug in positive t's and only generate positive x's, then over here, I need to make a note that x must be greater than or equal to 0. My rectangular function still has to match up and generate the exact same image that I would generate over here if I was solely picking values. So in rectangular coordinates, I need to make sure that I add in this extra piece about the domain and range. When I go to graph, I'm just going to make a quick sketch here. Right? I know that this looks like kind of like a parabola, right? It's x to the 4th. It's shifted down 2 units. And so I would have something like this, right? I would have less than 1, because it'd be like the 4th root of 2. And it comes up, and I can only choose positive values. So it would be sort of half of that parabola type shape. And again, I would need to plot a couple points using just my parametric, right? This gives me a really quick way to get to the shape without having to worry about picking the right t's. But I do lose out when I convert over on figuring out the orientation. So I'll pick a couple of t values. We'll make them easy, right? When t is 0, I would generate the square root of 0, and 0 minus 2 is minus 2. So that piece down here would correspond to t equals 0. And t equals 1 would be a nice easy selection, right? The square root of 1 is 1, and 1 minus 2 is minus 1. So that coordinate right here would be the coordinate where t was equal to 1, which would mean that my direction, my orientation here, if I'm starting at 0 and heading towards 1, I need to follow this path. I'm starting at that y-axis, and I'm moving up the curve. So I add my orientation arrows. All right, so you got to check your domain and range of your x's and your y's so that you can verify that you don't have to make any edits over in the rectangular form. We're getting closer. There's a lot of notes to 10.6. Here's another one. If you want to challenge yourself, turn off the video, see if you can figure it out on your own. Right? On this one, the work is a little bit messier. Right? I could go ahead and start thinking about how to convert this over, but I also want to pay attention, right, that x, I can never choose, right, -1. Here, I would get an undefined value, and same thing here. I also need to make sure that t plus 1 is greater than 0, so that x would be defined. So t has to be greater than -1. Notice not equal to, although I can evaluate the square root of 0, I can't divide by that. So if t is not greater than -1, then y of t would be undefined, or x of t would be undefined. So I need to make sure that I insert that into my domain when I convert it over. Right? The hard part here would be picking appropriate t values. How many are you going to need? It's not just linear functions. I'd have to think about a lot of different t values. So converting it over is going to give me a much better idea of the image here. In order to switch to the other form, to rectangular form, I will take that one and I'll solve for t. So I'll square both sides. And I can think about it as cross multiplying or taking reciprocals of both sides. Lots of ways to solve this one for t, but t plus 1 would be 1 over x squared, and t would be 1 over x squared minus 1. If that's true, then I'll take that back and plug it into my y. So I'll have 1 over x squared minus 1 divided by 1 over x squared minus 1 plus 1. Right? That is my t up top and my t plus 1 on the bottom. The quickest way to get rid of all the fractions floating around, when you have compound fractions, multiply top and bottom by that common denominator between all of the different compound parts. So here, if I distribute into the top, the numerator, 1 over x squared times x squared is just 1. And then minus 1 times x squared minus x squared. On the bottom, right, I could have probably actually done a little bit of distribution or simplification beforehand. Minus 1 plus 1 is going to cancel. And underneath, I'll have 1 over x squared times x squared. So that would just be x squared. Oh, math error. 1 over x squared times x squared is not x squared. It is 1. So overall, this curve would look like 1 minus x squared. However, I have to add in, right, if t is only greater than -1, then what's going to happen to these values right here? Right? You're going to never generate a 0 because of the division by 0, and you'll only have positives. So what do you know? You know that x must be greater than 0. So when I graph this parabola, I'm only going to graph the right-hand side. And we'll make a quick sketch. Right? It's a lot easier to graph this than it is to try to pick the appropriate t values. So let's see, I should be up 1 unit. And I would have a 0 at 1. I need an open circle because I cannot actually equal 0. And then it would fall. I'm choosing those positive values. So it looks something like that. I still have to account for the orientation. So I would want to still go back and pick a couple of t values. If t is, let's see, 1, I would get 1 over the root of 2 and 1 over 2. And for a second, I thought I couldn't choose it, but you know what? We can choose t as 0. T has to be greater than -1. 0 is a lot easier to plug in. When t is 0, I would get 1 comma 0, right? 0 over 1. So that is t equals 0. And t equals 1 is actually smaller than 1, right? 1 over root 2. So t equals 1, I don't know exactly where it is, somewhere around here. So actually, I would want to be moving in this direction. It's going closer and closer to the hole. As t increases, I'm sort of moving up my values. And so that's what that one would look like. All right, we're going to take a break and come back. We'll talk about how to deal with the trig.